पहले कल की क्लास के बारे में थोड़ा फर्स्ट हाफ आवर डिस्कस कर लेते हैं। वो प्रूफ नहीं कराऊंगा, बस प्रॉपर्टी लिखवा दूंगा ताकि अगर कोई बच्चा देखना चाहे तो देख सकता। ओके, so in yesterday class I am first talking about the property of mod and median. Okay, so I say suppose if we have an observation, say x1, x2 and so on xn. Okay, so on xn. Okay, any problem? Hello. So suppose median of this xi random observation, median of xi equal to x tilde me. Okay, now if y equal to g of xi, where g is monotone, where g is monotone function, monotone, right? This monotone means this is increasing or decreasing. Then median of y equal to g of x tilde median. Means if g is a function monotone means it decreasing or increasing function, then median of y equal to, just put the value of median in function. Okay, just put the value of median in function, you will get the median of y. So this is property of median. Okay, another property of mod. So suppose if x tilde mo is mod of xi, is mod of xi, and if y equal to g of xi and g is 1 1, if g is an 1 to 1 function, 1 1 function, okay, then mod of y equal to g of x tilde mo. Means if x tilde is a mod of xi and this function is defined in this way and g is an 1 1 function. Okay, if this g is 1 1 function, you can find the mod of y equal to g of x tilde mod. Okay, means here putting the value of x in term of x, put the value of mod of x. Okay, so this is second property. And then I am discuss some question. Okay, but I am not discussing the question. The question is the corrected mean and corrected geometric mean. Okay, so I will send already slide so you can see here. But now I am discuss the property of, sorry, now I am discuss absolute measure of, first I am discuss measure of dispersion, then absolute measure of dispersion. So absolute measure of dispersion, absolute measure of dispersion, ये कल मैंने सब कुछ करा दिया था लेकिन रिकॉर्ड नहीं हो पाया था कल बाय मिस्टेक, तो वही मैं फिर से रिपीट कर रहा हूं। कल की क्लास में सब कुछ हुआ था, मैं बस आज फार्मूले लिख दूंगा, प्रूफ मैं ओमिट करूंगा। प्रूफ के लिए आप लोग किसी बुक को एससी गुप्ता या गुण गुप्ता दास गुप्ता बुक में उसमें फॉलो करके, या मेरी स्लाइड में मैंने जो पहले कल की स्लाइड भेजा था उसमें प्रूफ मैंने सारे करवाए थे, आप उससे हेल्प ले सकते हैं। In yesterday class I am already done the proof. Okay, so here today I am discuss only facts, only properties, only result. Okay, because yesterday class is not recorded by mistake. Okay, so what is the absolute measure of dispersion? So first measure is range, and second measure is MD, mean deviation. Third, standard deviation and variance, and fourth is quartile deviation, QD. Okay, so first I am talking about range. So what is range? So range, this is defined as range equal to, suppose we have n observation xi, n observation. So range equal to maximum of xi minus minimum of xi. Okay, in this property of range, first property, if all xi equal to c, then range equal to 0. Okay, second property, if r of x is range of xi, define yi equal to yi equal to a plus bxi. Okay, I equal to, for each I equal to 1 to so on n. Okay, then range of y denoted by r of y is equal to mod b range of xi, rx. Okay, so this relation hold. Okay, so two property of range. First, range is if all observation equal, called c, yes, say c, then range equal to 0, and this is a property of range. Second property, change of scale and origin. Okay, so range, now we are discussing about mean deviation. Okay, and range is used in SQC. Okay, SQC, statistical quality control. Okay, so now I am discussing about mean deviation. So what is mean deviation? Mean deviation is 1 upon n summation mod of xi minus x bar, I equal to 1 to n. This is the formula of mean deviation. This is called okay. So first talking about deviation. Okay, so suppose what is deviation? Deviation di equal to xi minus m. This is deviation from point about point m. This is deviation of about xi about m. Okay, so this is about m. Okay, about point m, या m. Okay, so now mean deviation about point m, mean deviation about point m, या about m, is defined as m md mx equal to 1 upon n summation I equal to 1 to n mod of xi minus m. This is mean deviation about m. Now we are putting the value of m equal to x bar and median. If m equal to x bar means mean, then we find mean deviation about mean. then we find mean deviation about mean. Mean deviation about mean. Mean deviation about mean. About mean. So this is denoted by MD x bar of x equal to 1 upon n summation I equal to 1 to n xi minus m. Sorry, xi minus x bar. So this is mean deviation about mean. Now mean deviation about so mean deviation about median. Okay, about median. Now putting the value of median m equal to x tilde ma. So this is mean deviation about mean. So this is denoted by md x tilde ma x equal to 1 upon n summation I equal to 1 to n mod of xi minus x tilde m. यहाँ अगर किसी को डाउट हो, if anyone have doubt, you ask. Okay, I am repeat previous class. So this is xi minus x tilde. Okay, now if I put m equal to x tilde mo means mod. This is mod of xi. This is mod of xi. Okay, so mean deviation about mod, mean deviation about so this is nothing but this equal to md x tilde mo x equal to 1 upon n and summation I equal to 1 to n mod of xi minus x mo. Okay, so this is the basic definition of median. Now I am discussing about properties of mean deviation. So property of mean deviation. So first property, what is the first property of mean deviation? Anyone? If MDM x is mean deviation of xi and define yi equal to a plus bxi for each I equal to 1 to n. Okay, this is the symbol of 1 to n. Okay, so now mean deviation of y, mean deviation of about point m of yi, this is equal to mod of b mean deviation about point m of xi. Okay, so this is called scale and origin effect. Okay, this is also called scale and origin effect. A plus bi, this is called scale and origin effect. तो मैंने बताया था कल, we are discussing in yesterday class कि there is no effect of origin but there is a effect of scale, and scale effect of scale is just mean deviation of yi equal to mod of bi. So it doesn't matter if b is positive or negative. If this b is positive, then mean deviation is same. If this b is negative, then mean deviation of y is equal. Okay, so first property. Second. Okay, second property, if 1 upon n summation mod of xi means mean deviation about m equal to 0 if and only if xi equal to m. If mean deviation about m, if mean deviation of xi about m equal to 0, then if and only if xi equal to m. Okay, third property, if 1 upon m summation I equal to 1 to n mod of xi minus m is minimum is minimum is minimum, then this m equal to median of xi, median of xi, median of xi. Okay, this is important property. Okay, this is important property. This property is very important because this property is used in statistical inference also. Okay, when you find out the MLE of double exponential or Laplace distribution, if anyone want to find the MLE of double exponential or Laplace distribution, we can use this property. Okay, mean deviation about mean is minimum, so we can take the here median is MLE. Okay, if anyone remember, you can recall this because the 1/2 e के power minus x minus theta. Suppose this is my PDF. What is the MLE is here? What is the MLE is here? So how to find the MLE? If anyone remember, here we can use this property. Okay. So property of mean deviation is first property, second property. Wait a second. Right. Okay. Third absolute measure of dispersion is variance. Okay. So first we talk about mean square deviation. Okay, mean square deviation, mean square deviation, mean square deviation. So this is equal to s square equal to 1/n summation I equal to 1 to n xi minus m square. This m is any point. Okay, this m is any point. This m is any central value, any central value, any central value. Okay, central value. Okay, so this is mean square deviation. This is denoted by s square. Now root mean square deviation. Root mean square deviation. So root mean square deviation is nothing but root mean square now root mean square deviation equal to, this is s equal to under root 1 by n summation I equal to 1 to n xi minus m. Okay, you can also write here not m, here write alpha, b, a, anything. This is any central value. Okay, this is not fixed, this m is not fixed, so you can use any symbol here, m, capital A, capital B, small b, anything. Okay, so this is called root mean square deviation. Okay, now if I put m equal to x bar, say mean. Okay, this is mean of xi. Okay, so s square equal to 1/n summation I equal to 1 to n xi minus x bar square. So this is called variance. This is called variance of xi. This is called variance. Okay, this is the formula of variance, and this is denoted by sigma square. Okay, sigma square. Now if I put m equal to x bar in root mean square, then s equal to under root 1/n summation I equal to 1 to n xi minus x bar square. So this is called standard deviation. Okay, this is called standard deviation. standard deviation of xi, and it is denoted by sigma. Okay, most time it is denoted by sigma, right? Now remember one thing, variance of xi always greater or equal to 0. Why this is always greater or equal to 0? Because this is a positive quantity, and when we added this positive quantity, this is greater or equal to 0, right? And here you also think variance of xi equal to under root variance of xi equal to standard deviation of xi. Okay, okay, sd of xi equal to root of positive root square of variance of xi. Okay, so now see properties of variance. Properties of variance. Properties. So first property, if all xi equal to c, then variance equal to variance of xi equal to 0 and sd corresponding sd equal to 0. Standard deviation of xi equal to 0. Right? You can prove this easily. If all xi equal to 0, this is first property. Second property, variance of xi is also expressed in this way, 1 by n summation of xi square minus x bar square. Okay, right? I equal to 1 to n. Okay. Third property is important property. This is called scale and origin change. Scale and origin effect. Scale and origin change. Origin change. So suppose now scale and origin change. Okay, scale and origin change. Origin change. So okay, first here suppose we have n observations say xi, we have n observations say x1 x2 xn, insert say xi, I equal to 1 to n, I equal to 1 2 so on n. Okay, so now define yi equal to a plus bxi, or this is same way where I define yi equal to xi minus a by h. These are simple, right? Okay, चाहे ये लिखो चाहे ये, इफेक्ट वही होगा. ठीक है. So here what are you see? Here you see variance of yi equal to b square variance of xi. Okay, and standard deviation of yi is equal to mod of b standard deviation of xi. Okay, variance is not affected by change of origin, but it is affected by change of scale. Okay, and it is square of that scale quantity. Okay, if we multiply or divide any quantity, then variance is also change. If I add and subtract any quantity, then variance is no change. Similar way SD is change and SD is not change, because variance equal to SD equal to root of positive square root of variance. Okay, right. सो कल तक मैंने यहीं तक डिस्कस किया था. कल मैंने इस प्रॉपर्टी को करके एक क्वेश्चन करके मैंने एंड कर दिया था. राइट, इस प्रॉपर्टी के बाद एक क्वेश्चन मैंने करवा के एंड कर दिया था. सो ओके, आई विल स्टार्ट ए टुडे लेक्चर. ओके, सो दिस इज टुडे लेक्चर. ओके, सो फर्स्ट So first thing I am writing in yesterday class, I am writing this quantity. Okay, MD is greater SD. So this is prove or disprove thing. Actually I am want to say this is prove, this is you want, I am writing that this is correct or wrong. Okay, so you prove or disprove this sentence. Prove or disprove this sentence, or disprove. So how can you prove or disprove this? Anyone? This first, this is correct or not correct? Anyone?
I think so, correct.
It is correct. This is I want to say this is correct or this is correct. This is correct or this is correct. Okay. Mean deviation
Is the minimum?
सो ओके, देखो ये क्वांटिटी जो लिखा है ये फॉल्स लिखा है, ठीक है, दिस इज रॉन्ग. एस डी इज ऑलवेज, स्टैंडर्ड डेविएशन इज ऑलवेज ग्रेटर देन मीन डेविएशन. ओके, and mean deviation, remember this mean deviation about mean. Okay, this is mean deviation about mean. Mean deviation about mean. Okay, this is x bar, right here, right, x bar. Okay, so this quantity is false, this relation is false, this relation is true, this is true. So okay, we prove this true relation. How can we prove? So first write here SD greater MD, mean deviation. Okay, so now SD square greater MD square. I am squaring both side. Now what is SD square? This is nothing but this equal to variance. So this is equal to 1 upon n summation xi minus x bar square, I equal to 1 to n. Okay, this is greater or equality, or you take equality case. Okay, so what is MD? 1 upon n summation I equal to 1 to n xi minus x bar mod में whole square. Mean deviation about mean is mean deviation about mean of x equal to what? This is equal to 1 upon n summation I equal to 1 to n mod of xi minus x bar. Okay, so now transfer this part, so you can write minus 1 by n summation I equal to 1 to n mod of xi minus x bar whole square. This is greater or equal to 0. Okay, anyone problem in these step? You can ask. If anyone, any person, any problem in these step, ask. Here just I am writing just definition of each quantity. Okay, definition of standard deviation square means variance, mean deviation square, mean deviation, then we take square. Okay, so now I am getting 1 upon n summation xi minus x bar square minus 1 by n summation I equal to 1 to n . mod of xi minus x bar square. Now put remember one thing, this is greater or equal to 0. Now put mod of xi minus x bar equal to zi. Okay, so this first quantity equal to 1 upon n summation zi square, I equal to 1 to n, and second quantity is 1 upon n summation I equal to 1 to n zi square, and this is greater or equal to 0. Okay, so what is this? This is equal to 1 upon n summation I equal to 1 to n zi square minus this is z bar. Okay, this is the mean of z, this is mean of z, so this is z bar square. This is greater or equal to 0. So what is this formula? What is the value of this formula? 1 upon n I equal to 1 to n zi square minus z bar square. Anyone?
Variance of zi.
Okay, so this is variance of zi. Okay, so this is variance of zi, right? This is variance of zi. So variance of zi greater or equal to 0. We can find variance of zi greater or equal to 0, which is always true. This quantity is always true, because I am saying that this is property of variance. This quantity is always true. So we can say, we prove this SD is always greater than MD. Okay, SD is always greater MD. We can prove this quantity because we find a positive result which is always true. If we find a positive result which is always true, then that means what I am proving, this is right. Okay, if I find here a contradiction, then this is not true. When you want to prove this quantity, you got a contradiction. Okay, you got a contradiction. So when you got a contradiction, then this quantity not. When you want to prove this result, you got a contradiction, this result is not true. Okay, but here you find a positive result, means you find a always true result. If you find a always true result, this result is always true. Okay, so this is the proof of SD greater or equal to MD. Okay, right? SD greater or this is true. This is a theorem. Okay. So okay, okay. So now suppose another question, another example. So suppose we have a series. Okay, we have a series which is AP. Okay, A plus 2D. Sorry. A plus D, A plus 2D, so on, A plus 2ND. So how many terms in this series? In this series in AP. Okay, series in AP. Okay, AP means arithmetic progression. Suppose we have a series which is in arithmetic progression. So what is the number of terms here? Anyone? This is started from A plus D, A plus 2D, so on A plus 2ND. So how many number of terms here?
N plus 1.
2n plus 1.
Right. Here 2n plus 1 terms. Okay. Here 2n plus 1 terms. How you can calculate? You remember one formula. What is the formula of last term in Tn? Oh, sorry, last term in AP. What is the formula of last term in AP? Anyone? What is the formula of last term in AP?
Sir, first term plus n
Last.
minus 1. First term plus n minus 1 into d.
Okay.
D is
A minus n minus 1 into D. Okay.
a plus.
A plus or A minus?
A plus.
A plus. Okay. Now putting here the value of last term. So last term is A plus 2n D. And first term is A. And now suppose here M term. Okay. Now suppose here K term. Okay. Now suppose here K term. Okay. So okay. So this A cancel out. Now you find this 2n D equal to K minus 1 into D. So this D and D are cancel out. So you find K equal to 2n plus 1. Right? So in this way you find the number of terms in AP. Okay. One question asked in GATE on base of this. Actually in GATE exam, question is asked in this scenario. Suppose we have 1, 3, 5, 7 to 9, 9. Okay. Suppose we have this series 1, 3, 5, 7, 99. Okay. And this is a discrete uniform distribution, right? This is followed discrete uniform distribution in the way 1, 3, 5, 99. Then examiner ask what is the expectation of x given x is not multiple of 15. If you have good knowledge of series, you can find the answer of this question. Okay. So okay, this is the number of so here 2n plus 1 term. Okay. Now my series is A plus D, so on, A plus 2nd. Okay. Now this is xi. Okay. So first, what is the mean of this series? What is the mean of this series? Anyone? What is the mean of this series? First here calculate mean. Okay. What is mean of this series? Achha, what is the mean of any AP series? Anyone? Achha, give a hint.
First term plus last term divided by number of terms.
No. I give you apply to you first think two numbers 1 or 2, then find their arithmetic mean and generalize for n numbers. This is generalized for n numbers. So when you think about two numbers 1 or 2, what is the mean? 1 plus 3 by 2. Sorry, 1 plus 2 by 1 plus 2 by 2. Okay. Suppose you have thinking two number 1 or 2. What is the mean of this two number? 1 plus 2 by 2 means 1.5. This means 1 plus 2 by 2. Okay. 1 plus 2 by 2 means first and second. Adding first and last number and divide by 2. This is the mean of AP series.
Sum of AP 1, 2.
Why this is mean of AP series? Because if anyone remember, the sum of AP series equal to Sn equal to n by 2 if we have n terms. Okay, n by 2 A plus L, where L is last term. Okay, A plus L where L is last term. Okay, L is last term. Sn equal to n by 2 A plus L, n is number of terms here and L is last term. Now suppose here we divide n, then we get mean. So you take here n. So this n remove here. So this is Sn by n equal to mean, na? This Sn by n equal to mean. This is mean. So this mean equal to first plus last term by 2. Okay. So mean of any AP series is equal to first plus last term by 2. Okay. So mean of any AP series equal to first term. So first term equal to A and last term equal to A plus 2 and D by 2. So mean of AP, this AP series equal to A plus N into D. Okay. So mean of this AP series equal to A plus ND. Okay. Now, what is mean? Mean equal to A plus ND. A plus ND. Now, xi minus x bar. What is the value of xi minus x bar? Here 2n plus 1 terms, and here this is the value of xi. This is the value of xi. Okay, this is the value of xi. So xi minus x bar. So write first number here a plus 2d, sorry, a plus d, a plus d, so on, a plus 2nd. So when we minus mean, you will get minus nd, right? When you here subtract mean, when here you subtract mean, you will get minus nd. Okay, a minus minus a minus nd, what is this? This equal to minus nd, right? So again you find minus n minus 1 into d, right? Minus n minus 1 into d. Okay, and here remember one term is a plus nd. Remember here one term is a plus nd. In this series xi term, one term is a plus nd. Okay, so here mean is 0. So here mean is 0. Okay, here mean is 0, and the last sorry, here not mean is 0, here deviation is 0. Okay, here not mean is 0, here deviation is 0, means xi minus x bar, the value of xi minus x bar equal to 0, because when you subtract a plus nd minus a plus nd, you will get 0 here. And what is the last term? What is the value of xi minus x bar in last term? This equal to nd, right? This equal to nd, right? This equal to nd, n into d. यहां तक अगर किसी को कोई प्रॉब्लम है तो बताए सीरीज पे। सबसे पहले हमने xi लिख दिया, xi हमारा एपी में था, मैंने मीन फाइंड कर लिया, और मीन का वी हैव फाइंड आउट द डेविएशन फ्रॉम मीन. दिस इज डेविएशन फ्रॉम मीन, xi minus x bar. This is the value of deviation from mean, and add this quantity, this deviation from mean equal to 0. You can add here this deviation from mean equal to 0. This deviation from mean equal to 0, because this is a property of mean. You can check here, this deviation from mean, this is 0. Okay, because this is minus nd, this is positive, so this minus nd and nd cancel out. Here n minus 1d is positive, here this is negative, so this and this quantity and 0, and above term is negative, and below term is positive, so this value equal to 0. This is nd. Okay, now what is the value of xi minus x bar square? Xi minus x bar square. So first value is n square d square, second value is n minus 1 square, n minus 1 square d square, right? And 0 के corresponding, the value corresponding to 0 is 0, and the value corresponding to nd is equal to n square d square. So now find out the, अब हमको यहाँ find क्या करना है? We are want to find mean deviation, about mean, and variance and standard deviation. We are find out three quantity: mean deviation, about mean, variance, and standard deviation. Okay, so we find out deviation xi minus x bar, and we find out square of deviation. So now what is the formula of mean deviation about mean? So mean deviation about mean, this is equal to 1 by n, but remember here n equal to not n, here n equal to 2n plus 1. So we can write here what value of this equal to 2n plus 1. Why this is 2n plus 1? Because here 2n plus 1 terms, यहाँ 2n plus 1 क्यों किया? क्यों? यहाँ 2n+1 लिखने का रीजन ये था बिकॉज यहाँ पर 2n+1 टर्म है, इसलिए मैंने यहाँ 2n+1 लिखा। अगर यहाँ n टर्म होते तो मैं n ही लिखता। ओके, so don't confuse, this is a formula, this is not formula, actually formula is mean derivation about mean 1 by n, where n is the number of terms, but here the number of terms is 2n+1. Okay, so we can write here first 2n+1, then summation I equal to how many term here, 2n+1, so you can 2n+1 mod of xi minus x bar, mod of xi minus x bar. So if I take here mod of each quantity, if I take here mod of each quantity, so first quantity is nd, second quantity is n-1 into d. So similar way, this is n-2 into d, this is 0, and this is blue 0. What is the value of blue 0? This is d, right? 0, here d, here you will get d. Okay, you can realize this, here you will get d, and here you will get 2d, and similar way nd. Okay, so this is equal to 1 upon 2n+1. So your first value is nothing but this equal to mod of minus nd. Second value is mod of minus n-1 into d. And similar way this series go, and here one value is d 0, here one value is 0, so mod of 0 plus similar way this go, and here this value is n into d mod. So you will get what? You will get 1 by 2n+1. So if I taking mod of any negative value, this is positive. So this is nd plus n-1 into d plus so on. And here one term is 0, and then started from d and so on. This go to nd, n into d, right? यहाँ तक सबको समझ में आया कि मैंने कैसे लिखा इसको। मॉड लोगे किसी नंबर का तो मॉड वो निगेटिव नहीं पॉजिटिव, निगेटिव मॉड हमेशा पॉजिटिव वैल्यू देगा क्योंकि मॉड इज अ पॉजिटिव क्वांटिटी। ओके, सो मैंने मॉड की वैल्यू को ओपन कर दिया, बी आर ओपन द मॉड, सो बी विल गेट एन डी प्लस n-1 into d plus so on plus 0 plus d plus so on nd. Now we add this series, so we get, see here, this term and this term are common. Beside 0 d plus so on nd, and here beside 0 here d plus nd, these terms are common. So we add this series in this way, we get 1 upon 2n+1 2 into d plus, otherwise starting from 0, so we add 0 in no meaning. Okay, so d plus 2d plus so on plus n into d. Anyone any problem? Why can we write here 2? मैंने यहाँ 2 कैसे लिखा, किसी को यहाँ तक दिक्कत कोई? 2 टाइम्स इस सीरीज के इक्वल मैंने क्यों किया? अगर दिक्कत है किसी को तो पूछ सकता है। If anyone any doubt related to this, you can ask. क्योंकि देखो इस सीरीज पे 2 सीरीज बन रही थी, एक ये सीरीज थी और ये दोनों सिमिलर सीरीज है, तो we can add this 2 times. Okay. So now here common d, you can common d. You can take common d, then you get 2d, 1 plus 2 plus so on plus n. Okay, 1 upon 2n plus 1. So 1 upon 2n plus 1. And what is the summation of n? What is the summation of 1 plus 2? I equal to 1 to n, I equal to n upon n plus 1 by 2. What is the summation of first natural number? This is first natural number, first n natural number. Okay, this is first n natural number. So summation of first n natural number equal to n into n plus 1 by 2. So you can put the value here, n into n plus 1 by 2. So this 2 and 2 cancel out. So you will get what? You will get n plus 1 divided by 2n. Anyone write in chat box? Why you are writing in chat box? Please ask. Because my laptop is not near me, so I cannot read your chat. Okay, जिसने भी चैट बॉक्स में लिखा है एक बार वो अपना क्वेरी पूछ सकता है, क्योंकि मैं चैट बॉक्स नहीं देखता हूँ भाई, मैं चैट बॉक्स नहीं देखूंगा। चैट बॉक्स मैं तभी देखूंगा जब मैं क्लास एंड करूंगा, बिकॉज माई लैपटॉप इज नॉट नियर मी एंड दिस इज लाइव क्लास, ओके, सो यू कैन इंटरेक्ट विथ मी। आप अपना डाउट पूछ सकते हैं, ठीक है। अदरवाइज मुझे चैट देखना पड़ेगा, 1 मिनट देखते हैं। ठीक है, किसी ने नहीं किया। So okay, now we are finding out the variance. Okay, so finding out variance, this term, first find this term, summation I equal to 1 to n xi minus x bar square. So what is the value of first xi? Remember this, here I am writing 2n plus 1 term, okay, 2n plus 1 term. So first term is, see here, when we are adding this term, so see here, below 0 these quantity and above 0 these quantity are equal, so we can add it in this way, 2 multiply 0 plus d square plus 2d square, 2 square d square, okay. So we can write here in this series, if we added this series, we get what? We will get, see here, we will get 2 times d square plus 2 square d square plus 3 square d square plus in similar way n square d square, right? When we are adding the square term, we will get this series, okay. So now you common out d square, you can take common d square, you will get what? 1 square plus 2 square plus 3 square plus so on plus n square. Now what is the sum of square of first n natural number? So summation of I equal to 1 to n I square, this is equal to n. Anyone? What is the value of this summation?
n into n plus 1 cos n plus 1 divided by 6.
N into n plus 1 2n plus 1 divided by 6, right? This is the value of this quantity. So now putting here the value, when you put the value, you will get 2n d square n plus 1 2n plus 1 by 6, right? So you can simplify the term, you will get n plus 1 2n plus 1 divided by 3 d square, right? n plus 1 2n plus 1 by 3 d square, okay. Now so what is variance? So variance of xi equal to, how many term is here? 2n plus 1, so 2n plus 1, okay. Now what is some value of summation? This we will get n plus 1 2n plus 1 by 3 d square, okay. So 2n plus 1 will cancel out, you can cancel 2n plus 1, so you will get n plus 1 by 3 d square. Now what is standard deviation? So standard deviation of xi, you will get root over n plus 1 by 3 d, right? This is standard deviation and this is variance. So this is an important series, and question direct asked in this series, I will give, suppose I will give 1 3 5 7 9 so on 99 number, okay, and then ask what is the standard deviation of this series and what are the mean deviation of this series, okay. So suppose I give a question 1 3 5 7 and similar way 99, okay. So I am asking you What is the mean deviation of mean deviation about mean? Mean deviation about mean. About mean. First option, wait a second. So first option is first option, second option is third option is fourth option is what is the value of mean deviation about mean? Anyone? What is the value of mean deviation about mean is here? What is the value of mean deviation out here? Mean about mean here. Wait a second. Wait. Not these option are not any option is not true. Okay. These any option is not true. Now find. Okay. Now finding. Because here we cannot apply that formula. Okay. Because here 2n plus 1 term. Okay. In the series previous series 2n plus 1 term. Okay. So we cannot apply the formula direct here. Okay. So if I want to find the mean deviation about mean, so we can further proceed like previous question. So this is 1 3 5 series. So how many term is here? What is the number of term here? How many term is in this series? 1 3 5 7 so on 99.
50.
Okay, 50. So what is the mean? First, what is the mean of this data? Mean equal to 50. Mean is not change. Mean is not change. Mean first term and second term by 2. So 9 plus 99 plus 1 equal to 50 by 2 equal to 50. So now mean is 50. Okay. Now mean is 50. So what is xi minus x bar? What is the value of xi minus x bar? Xi minus x bar. So first value is minus 49 and last value is positive 49. Okay. And this value equal to minus 47 and last here one value is 47. So you will get what? You will get minus 49 to minus 47 then 49. So how this series started? Here one term you find 49, okay? Now deviation is equal to xi minus a value of xi minus x bar equal to what? This is first minus 49, then minus 47, then minus 45, and here you find out similar way. Here one value is 47, 49. But here you can find one value is 0. Here find any value 0, because this is a odd number series, so we can not find here the value 0, because here not any term is 50. In this series not any term is 50, so we cannot find any value 0. So what is the minimum value of this deviation? What is the minimum value of this deviation? Anyone? What is the minimum value of this deviation? Minus 1, right? Minus 1. Okay, so here minus 1. And what when the value is minus 1? When we take xi equal to 49, then value is minus 1, right? So here also one value is 1. So you can, when you can add this, so you add 2 into 1 plus 3 plus so on plus 49. Right? So what is the summation of this series? 1 plus 3 plus so on 49.
45 square.
25?
25 square.
25 square. Okay.
Yes,
now, how many term is here?
25 times.
25. And remember the thing, if I added the first n natural number, so this is equal to n square. This n square equal means, this n means here the number of terms. Okay, here the number of terms 1 plus 3, not this n. Remember thing, this not this n, okay, this is not this n. This n equal to number of terms here, or you can written here this equal to number of term square. Okay, so this is the summation of first n natural odd number. First n natural odd number, the summation of first n natural odd number equal to how many term is here, then square that term. So okay, so this is the series of natural odd number. Okay, this is natural odd number and there is 25 odd number. So you can easily 2 into 25 square. So 2 into 25 square equal to 1 into 2, 6, 625. So this equal to 50 and 12, 1250. Okay. So this is deviation, right? This is sum of deviation. So this is mod of xi, summation mod of xi, I equal to 1 to 50. 1 to 50, right? So now, what is mean deviation? So mean deviation क्या होगा? Mean deviation आपका जो होगा ये वैल्यू आएगी 1/50 into 1 to 5. So when we divide this, you will get 2, 5, 25. So this 25 is answer. This 25 is answer. This 25 is answer. देखो ये सीरीज पीछे वाली सीरीज से थोड़ा डिफरेंट थी तो ये एपी, लेकिन वहां पर टर्म अलग है, यहां पर टर्म अलग है. तो या तो आप एक चीज फाइंड करिए, वहां पर जो टर्म है 2n+1 उसको आप कन्वर्ट करिए, लेकिन इसमें उसको कन्वर्ट करिए पहले n के लिए, मतलब पहले आप निकालिए ऐसी सीरीज का सम जो n के लिए हो, मतलब मीन्स आई वांट टू से फर्स्ट यू फाइंड वन, दिस इज योर होमवर्क, ओके, दिस इज योर होमवर्क क्वेश्चन, व्हाट इज द वन टू थ्री so on r, wait, r a plus d so on a plus nd, these are ap series, this is ap series. So first find this ap series mean, variance, mean deviation, standard deviation. Find this ap series mean, variance, standard deviation and mean deviation. Mean deviation. So okay, first find this standard AP series mean, variance, standard deviation and mean deviation. Then apply. Then this formula is applicable in this series. Okay, this formula is applicable in this series. This formula is applicable in this series. Otherwise you find that way I am solve the previous question. Okay, अगर यहाँ तक किसी को कोई दिक्कत हो तो पूछे, अदरवाइज मैं आगे फर्दर टॉपिक में मूव करूं. किसी को कोई डाउट है यहाँ तक की क्लास पे?
सम ऑफ इवन सीरीज के लिए सम क्या होगा सर?
इवन सीरीज के लिए किसका सम?
जैसे ऑड के लिए हमने एन स्क्वायर लिखा ना, तो वैसे इवन अगर आ जाए 2 4 6,
तो यू कैन चेंज इन ऑड ना, 2 + 4 + 6 so on. Suppose this is, how many term is here, you can calculate here. Suppose this is 2n square, okay, right? So you can convert in odd number na, you common 2, so this is 1 + 2, sorry 1 + 2 + 3, so you can convert in this series na, 2n, so you can convert in this series, so this is multiplied by 2 and n plus 1 by 2, right? And if 2 cancel out, you will get n plus 1 by 2. Okay, समझ में आया? अगर 2 + 4 + 6 so on 2n टर्म है, तो इसको आप कन्वर्ट कर सकते हैं ना, 2 कॉमन लेके इसको नेचुरल नंबर की सीरीज बना लीजिए, इसका इस सम को फाइंड कर लीजिए. ठीक है, ओके, तो आई मूव टू फॉरवर्ड. अब हाँ देखो, अब हम बात करेंगे, एक चीज मैं आपको होमवर्क देता हूं, दिस इज योर होमवर्क. मैंने एक क्वेश्चन बताया था आपसे कि हमारे पास एक, सपोज करिए n ऑब्जर्वेशन का डेटा है, वी हैव सपोज n ऑब्जर्वेशन, सपोज वी हैव n ऑब्जर्वेशन x1 x2 and so on xn, right? We have n observation, okay, and suppose this observation and error x1 has x1, okay, right, x1 has an error and replaced by x2, replaced by x1 dash. I am talking about this type of question, right? Suppose we have n observation x1 x2 xn and x1 has an error and replaced by x1 dash. Okay, so we find out what? We find out already mean. Mean मतलब am, arithmetic mean, and gm, geometric mean. So now target is finding the variance. What is the variance of xi? corrected variance. What is the corrected variance of xi? This is corrected. This is your homework. मतलब हमने कल की क्लास में जो डिस्कस किया था कि अगर हमारे पास एक डेटा है उसमें एक पॉइंट पे एरर है, एक वैल्यू पे एरर है और उसको मैंने ट्रू वैल्यू से रिप्लेस किया, सो उसके बाद आपने मीन फाइंड कर लिया, अर्थमेटिक मीन, you find arithmetic mean and you find geometric mean. Now target is this, now question is this, find the corrected variance or corrected standard deviation. You can find it easily, okay? So first you try in home, then you ask in class. I solve this question, okay? So now I am talking about combined series data. Now target is combined series data, okay? So now today I am talking about combined series data. Combined series data. Series data. So what is combined series data? Suppose we have two observations. This is n1 terms, say x1i, and here n2 observation, say x2j. Okay, and this I equal to 1 to n1 and this j equal to 1 to n2. So this observation is nothing but first observation is x11, x12, so on x1 n1, right? This is the n1 observation, and here x21, x22, and so on x2 n1, n2. So suppose we have n1 observation of x1 1i and I equal to 1 to n1, and second observation x2j and j equal to 1 to n2. Now what is the combined mean of this data? And remember this thing. And the mean of this data is x bar 1. This is mean. And the mean of this data is x bar 2. This is mean. Okay. Okay. x2 bar mean of n2 observation and x1 bar is mean of n1 observation. So combined mean or pooled mean or grand mean. So grand mean or pooled mean. So grand mean or combined mean or pooled mean is equal to, say, x bar. This is denoted by x bar, okay? So this is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. You can prove this, okay? If anyone want to prove this, you can prove this in home. Otherwise, you can see this is available in SC Gupta, BK Kapoor, or any standard book, Das Gupta, Gun Gupta, okay? Anyone message? Anyone chat inbox? Why you can chat? I say, my laptop is not near me, so I cannot see chat. अगर किसी ने चैट किया है तो अपना डाउट पूछ ले, ज्यादा बेटर होगा, बिकॉज अगर मैं चैट देखूंगा नहीं उसका डाउट बताऊंगा नहीं. Okay, so this is the pooled mean, okay, right? Grand mean, pooled mean, okay. So now you can prove this in home, okay. So this is arithmetic mean, this is pooled arithmetic mean, okay. This is for arithmetic mean, okay. Remember one thing, this is arithmetic mean, okay. So this is for arithmetic mean. Here you write this is for arithmetic mean, okay. Now suppose in general, we are talking about in general. So what is the in general? Suppose we have t set of values. Suppose we have t set of values. T set of values of t set of values like 1 to so on t, and their size is n1, n2, and nt, and mean, respective mean equal to x1 bar, x2 bar, and xt bar. Okay, suppose we had t setup values. What is the value? Size 1 to t, and this is the serial number. Okay, size n1, n2, nt, and mean is this. Then total pooled mean या combined mean x bar equal to summation I equal to 1 to n, I equal to 1 to t, ni summation I equal to 1 to t, ni x bar I divided by summation I equal to 1 to n, 1 to t, ni. Okay, 1 to t, this is t. This is x bar, xi bar. Okay, so this is formula. This is combined mean or pooled mean. This is pooled mean or combined mean. This is pooled mean or combined mean. Okay, right? We have this type of set. This is pooled arithmetic mean. Remember this, when I am talking about mean, this is arithmetic mean. Okay, not this is geometric mean or harmonic mean. This is arithmetic mean. Okay, so this is in general formula. Okay, now we are talking about geometric mean. Okay, so now when we are talking about geometric mean, so right here geometric mean. Okay, so geometric mean for combined series. Okay, this is for combined series. Combined series. So first you have first series and then second series. Okay, so the first series have n1 observation and this geometric mean is g1, and second series had 2 observation and this geometric mean is g2. This is gm, geometric mean, this is geometric mean, and this is size. Okay, this is size, so combined geometric mean या pooled geometric mean, combined geometric mean, combined gm, this equal to log of g, n1 log g1, n1 log g1 plus n2 log g2, n2 log g2, n2 log g2 divide by n1 plus n2, n1 plus n2, right? This is n1 plus n2. So this is for 2 series. Now you can generalize it. Okay, proof are already given in any standard book. We have not enough time, so we are omit the proof. Okay, you can proof in a standard book. If you want to know the proof, you can text me personal. I am send the proof. Anyone want to know the proof of this any result, you can send personal text. Okay, you can send me personal text. Okay, because in this session or in this CSIR-NET class, proof is not necessary thing. Okay, so result is important, proof is not important. Okay, so now suppose we have t set of values. Okay, we have t set of values. Say first 1 2, this is serial number. Okay, t, and suppose size equal to, size is given by first serial का n1 size, दूसरे का n2, and third का, and the size of last t equal to nt, and respective gm equal to, geometric mean equal to g1, g2, and so on gt. So combined geometric mean equal to combined geometric mean, combined gm. So this is denoted by g. So log g equal to combined gm means g. Okay, so log g equal to summation ni log gi, log of gi divided by, here I equal to 1 to t, here I equal to 1 to t, summation I equal to 1 to t ni and I. So this is the formula of combined geometric mean, right? You can easily prove this, okay? There are no difficult tasks. Proving this is no difficult. So remember this thing, this is log g, not g, okay? So when we take g, this is anti-log, okay? This is exponential term, okay? So this type of error in occur in exam. This type of error in occur in exam. You can find the value of log g and see the option. You can tick the option of log g, okay? And your answer is wrong. So remember this thing. First you find log g, then you find the exponential of log g equal to g, okay? अभी जब हम क्वेश्चन when we are trying to solve the question or when we are discuss the doubt class or doubts of discussion or doubts of assignment, we can think this type of silly mistake, okay? So now what is the combined harmonic mean? Combined harmonic mean. Combined harmonic mean. Combined HM. So suppose we have one series and two series. So first is n1 number, second is n2 number, n2 size. Okay. So this geometric mean is h1, this geometric mean is h2. Okay. So their combined geometric mean, combined HM, sorry. This is first harmonic mean, this is second harmonic mean, and combined harmonic mean, combined HM equal to H, this is equal to H, n1 plus n2 divided by n1 by h1 plus n2 by h2. Okay, wait a second. I am writing here. This is capital H. This is combined harmonic mean. So this is n1 plus n2 divided by n1 by h1 plus n2 by h2. So you can generalize this, okay? You can generalize this. This is combined harmonic mean, okay? One, you check this formula, okay? One, you check this formula. If this formula is wrong, you can text me, okay? I am checking. Wait a second. Okay, you can check, okay? You can check. If anyone find any error, you can. So suppose we have T set. So you can generalize similar way. T set of values. T set of values. Suppose we have T set of values, size 1, 2, so on T, serial, size equal to first n1 size, second n2 size, and last is nt size, okay? So hm equal to respective hm, h1, h2, and ht, okay? So combined h equal to combined harmonic mean, combined harmonic mean h equal to ni summation ni I equal to 1 to t divided by summation ni by hi I equal to 1 to t. So this is combined harmonic mean, okay? This is pooled harmonic mean or combined harmonic mean. So okay, we are talking about the combined series. First we are talking about arithmetic mean. Then second I am talking about geometric mean. So this is the formula of geometric mean. Okay, wait. Okay, one slide is left. Okay, no problem. So this is the formula of combined geometric mean, and now I am talking about combined variances. So one question is asked in CSIR-NET in combined variances, okay? So okay, we are talking about combined variances. So combined variances, combined variance. Okay, so suppose we have first series, we have second series, so we have n1 term, we have n2 term, we have s1 square, this is variance, and this variance is s2 square. Okay, s2 square, this is variance. Okay, sample variance, this is sample variance. Okay, no problem. n1 n2, okay, and mean is x1 bar and mean is x2 bar. Okay, this mean is x2 bar, this is mean. Okay, this is sample mean, this is sample variance. Okay, we have two series. Okay, so combined variance s square equal to, so combined variance s square equal to combined variance s square equal to, wait a second. Okay, 1 second, wait. So combined variance s square equal to 1 upon n1 plus n2 bracket n1 s1 square, n1 s1 square plus n2 s2 square, n2 s2 square plus n1 n2 by n1 plus n2 n1 plus n2 by n1 plus n2 bracket x1 bar minus x2 bar square, right? Okay, so this is formula of combined variance of two series. This is combined variance of two series. Okay, two series. Remember this, this is combined variance of two series. Now this formula is also equivalent to, this formula is also equivalent. Suppose I define one di equal to xi minus x bar. Okay, and this x bar equal to combined mean. So this x bar equal to combined mean. So this is equal to n1 x1 bar. I am talking about two series. Okay, x2 bar, and here I equal to 1 to n, n1 plus n2. Okay, so di equal to xi minus x bar, I equal to 1 to n, and here x bar equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. So we are talking about combined. This is combined mean. This is combined mean. Okay, this is combined mean. This is combined mean, right? This is combined mean. So okay. So this formula s square equal to, this is also written as 1 upon n1 plus n2, then n1 s1 square plus d1 square plus n2 s2 square plus d2 square plus d2 square. So this formula is equivalent. Means combined variance equal to s square equal to 1 upon n1 plus n2 bracket n1 s1 square plus d1 square and n2, where d1 equal to what? d1 equal to x1 bar minus x bar. Wait a second. Where d1 equal to x1 bar minus x bar and d2 equal to x bar 2 minus x bar, and this x bar equal to this x bar equal to combined mean. This x bar equal to this. Now we can generalize this. Okay, now we can generalize this. Okay, so in general, this is important, right? In general, suppose we have k series, k series. So suppose 1, 2. So dot dot dot, this is K series. Okay. Now size is N1, N2. So this is Nk. And similar corresponding variance is S1 square, S2 square, and so on, Sk square. And corresponding mean is X1 bar, X2 bar, and Xk bar. Okay. Corresponding D1 is equal to X1 bar minus X bar. Corresponding D2 equal to X2 bar minus X bar. And this X bar is combined mean. Okay. Combined mean. So this is Dk, and Dk equal to Xk bar minus Xk, X bar. Okay. So this is variance, this is mean, and this is size. This is size. So we have, in general, we have this series. Okay. So what is the combined variance? So combined variance equal to combined variance of this series S square, you do not S square, this is equal to 1 upon summation I equal to 1 to K Ni and summation Ni sigma I, sorry, not, you cannot write sigma, Si square plus Di square, and I equal to 1 to K, and where Di equal to Xi bar minus X bar. X bar equal to summation Ni Xi divided by summation Ni, and I equal to 1 to K. Here also I equal to 1 to K. Okay. So here Xi and I equal to 1 to K. I am checking this formula. Wait a second. So right, this formula is fine. This formula is right. Okay. So this is combined variance for K series. Okay. In general. Okay. This is for 2 series. This is for 2 series. So now we are talking about quartiles. Okay. Now we are talking about quartiles, quantiles and quartiles, decile, percentile, octile. Okay. यहाँ तक अगर किसी को समझ नहीं आया है, if anyone any doubt regarding the previous slide, you can ask. Regarding any combined series mean, arithmetic mean, geometric mean, harmonic mean, or variances. Otherwise, I will start quantiles. So, okay, anyone define what is quantile? What is quantile? I am not talking about quartile. I am talking about quantiles. So, okay, suppose your pth quantile this is denoted by J या P. Okay, this is your pth quantile. This is denoted by J या P. Okay, so this equal to number of values less than J of P greater or equal to NP, and also number of values greater J P greater or equal to N1 minus P. So this is definition of pth quartile. Means pth quartile is this: the number of values below Chi P is more, P are more than P, and greater Chi P is also more 1 by p or more than p, then this number is called pth quantile. Okay, so this type is called pth quantile if number of values, what value? Number of values of xi, number of values of data. Okay, we are talking about xi. Okay, so this is our data. So number of values which is below chi p is more than p or more than equal to p, and the number of values is greater than chi p is more than 1 minus p or more than equal to or more than 1 minus p. So this is definition of quantiles. Now I am defining quartile. Okay, so now I am defining quartile. So quartile is nothing but this is Eg. So what is quartile? Anyone? What is quartile? Anyone?
Divides the data into 4 equal parts.
Okay. So if we put p equal to 1 by 4, then I will get chi 1 by 4. So this is first quartile. This is q 1 by 4. This equal to. If I put p equal to 2 by 4, then we will get chi 1 by 2 equal to q 1 by 2. This is the second quartile. If I put p equal to 3 by 4, we will get 3 by 4. So this is third quartile. This equal to q of 3 by 4. So this equal to third quartile. Okay. So this is first quartile. So this is first quartile. This is first quartile. So this is first quartile. This is second quartile. This is second quartile. And second quartile is also equal to median, right? Second quartile is also equal to median. This is third quartile. Okay. Now, so qi equal to I n by 4. This is, wait a second. So I am taking q2 equal to, so first you remember q2 means q2 equal to median. Okay, this is equal to median. So now what is the formula of quartile? How we find that? How we will find the data in quartile series? Suppose we have data, then how we find the quartile? Suppose we have x1, x2, xn data, x1, x2, xn data. So how can we find quartile? Like if we are want to find out mean, then we can add this and subtract the number of observation. And if we are want to find the median, then we can check if n is even, this is median, and n is odd, this is median. So how can we calculate quartile? Anyone idea?
One by 2 q3 minus q1.
एक बार थोड़ा लाउड बोलेंगे जो भी बोला है आपने.
So quartile division का formula q is equal to 1 by 2 q3 minus q1.
नहीं q2 माइनस q1 से आपने बोला, q3 माइनस q1.
q3 minus q1.
This is
quartile को minus करेंगे.
This is quartile deviation, right? This is quartile deviation, or this is called semi-interquartile range. I am talking how you find quartiles. Suppose you have 3 data. Okay. Suppose you have.
It depends on even or odd. Number of observations, even or odd.
Okay. हाँ. Please stop your mind. Mute yourself. Okay. So suppose we have data 2, 1, 2, 3, 4, 5, 6. And second data is 3, 8, 9, 10, 11, 12. And here you added 7. So now these are 2 series. Okay, first is odd number, second is even number. So how can find quartile in this series? I am talking about this series. Anyone?
So first one is
I into n plus 1 by 4th observation. I
Okay.
equal to 1 to 3.
So Qi equal to I
I
into n plus 1 by 4th observation.
of the arranged data.
Okay, okay. This is rearrange. This is arrange data. Okay. So this is arrange data. So this is in arrange data. Means ordering data. Okay.
Yeah.
This is ordering data. So how can you find the quartile in second?
Second is it's n by 4 I into n by 4 plus I into n by 4 plus 1 divided by 2. It's the average of
It's average, right?
yeah.
Okay, you say Qi equal to I into n by 4 observation plus n plus 1 by 4 observation.
n by 4 plus 1.
Okay, okay, हाँ wait. n by 4 plus 1 observation by 2, right?
Yes.
This is by 2. Okay.
So I should be for both the numerator. So
Numerator is 2 or 4 or not any number.
denominator is 2. In numerator, I should be inside the bracket I into n by 4. And here also I into n by 4 plus 1.
Here also I into n by 4. Here
Yeah.
also.
Yeah.
No, so I am inside I, okay? This is right. This is this I n by 4, okay? Okay, okay. Wait a second. You want to say this I n by 4, this I n by 4, right?
Yeah. Yeah. Yeah.
Okay. So, okay, there are many techniques. If you calculate in this way, this is also true. And there is one also technique. If n is multiple of 4 and is not multiple of 4, there is one formula is also given. Okay. Okay.
Oh.
So, in this way, this is true. Why this is true? Because you first find Q2. Okay. You find Q2. So, you find Q2, this is equal to median, right? If you put I equal to 2, I equal to 2, this is this formula equal to median. So, this formula is true. Okay. You can apply in journal this formula. Okay. But there is also one formula like n is multiple of 4 and n is not multiple of 4. So, there are different formulas. So, you can apply first this formula. Okay. This formula is right. ये फार्मूला सही है. किसी को नहीं पता तो ये लिख लो. फार्मूला यही होता है. पीछे का भी फार्मूला यही होता है. अगर यहाँ n, this n is odd. Okay, this n is odd and this n is even. Right, this n is even. Okay, right, this n is even. This n is even. Okay. So we are talking about quartile deviation. Now we are talking about quartile deviation. Quartile deviation. So what is quartile deviation? Anyone? What is quartile deviation?
So semi-interquartile range.
So quartile deviation of x equal to half Q3 of x minus q1 of x, and this q3 minus x this is known as IQR, means interquartile range. Interquartile range. Quartile range. Quartile range. Insert IQR, okay? IQR. And this QD, this quartile deviation is also known as semi-interquartile range. This quartile deviation is also known as semi-interquartile range. Okay, semi-interquartile range. Quartile range. So now we are talking about properties of quartile deviation. So first property. So now we are talking about scale and origin change. So first property is scale and origin change. Scale and origin change. Origin change. Okay. So now we are at first property scale and origin. अगर किसी को कोई प्रॉब्लम है इन फार्मूले में तो पूछ सकता है. इफ एनी हैव एनी डाउट इन दिस फार्मूला यू कैन आस्क. दिस इज द थर्ड क्वार्टाइल, दिस इज द फर्स्ट क्वार्टाइल. ओके, and the difference of q3 minus q1 is called interquartile range or IQR, and quartile deviation is also known as semi-interquartile range. Okay, now properties of quartile deviation. First property is scale and origin change. If QD of x is okay, if we have an observation xi and quartile deviation of this x equal to QDX. Okay, this is the quartile deviation of x. Now define yi equal to a plus bxi for each I. Okay, for each I equal to 1 to n. So what is the quartile deviation of y? QD of y. So this equal to mod of b QD of xi. QD of xi. This is QD of xi. Okay, ये जैसे as you change the standard deviation, as you change the mean deviation, in similar way this is also change. Okay, here doesn't any effect of origin, but here the effect of scale. Now we are talking about a question. Okay, so first consider one example. Suppose QD of x equal to 15 and define yi equal to 2 minus 5xi, I equal to 1 to n. Okay, then QD of y. First option minus 73, B option 75, C option minus 75, D option 73. What is the answer of this question?
Option B.
75.
Option B.
75.
So you can easily apply the formula. If yi equal to a plus bxi, this b is anything. Okay, this b is negative or this b is real number. Okay, this b is negative or positive. So your qd of y equal to mod of b and sd of xi. So okay, so sd of x, sorry, qd of xi. This is qd of xi. Okay, so b equal to -5, so mod of b equal to 5. So here b equal to -5. So qd of y equal to mod of -5 into 15. So this is equal to 75. So this is answer. Okay, 75 is answer. Now consider another measure of dispersion, which is most important in that sense. This is called Gini mean difference. Okay, suppose we define a measure delta equal to 1 upon n square summation I equal to 1 to n and j equal to 1 to n xi minus xj whole square, then this is called Gini difference of measure. Gini difference of measure. Difference of measure. So the beauty of this measure of dispersion, this measure of dispersion is not depend any central value. So this is the beauty of this measure of dispersion. This measure of dispersion is only depend on data. This measure of dispersion is not depend on any central value. Other measure of dispersion, it depend on central value. Okay, which some depend on median, some depend on mean, almost depend on mean. But this measure of dispersion is not depend on mean. You can easily prove delta equal to 2 times variance of xi or variance of xi. You can easily prove delta equal to 2 times variance of xi. How you can prove? See. So suppose your delta 1 equal to 1 upon n square summation I equal to 1 to n and summation j equal to 1 to n. Okay. Now xi minus xj square. So now add and subtract x bar. Okay, so xi minus x bar plus xj, minus xj minus x bar. This is whole square. This is summation double summation j equal to 1 to n and summation I equal to 1 to n. Here be added and subtracted x bar, when be minus x bar and here added x bar. Okay, you multiply minus, you will get plus x bar. Okay, now we are talking about this series. Okay, so now we are talking about this series. So right here, so summation I equal to 1 to n and summation j equal to 1 to n, xi minus x bar minus xj minus x bar, this square. So this is when you apply, wait a second, Okay, you can write this thing, na? Right. Okay. So when you can take, this is capital N, this is capital B. When you apply a minus b whole square, you will get summation I equal to 1 to n and summation j equal to 1 to n. This is x I minus x bar square plus double summation I am operate summation. Okay, I am operate summation in square both. Okay, so this is xj minus x bar square minus 2 summation I equal to 1 to n summation j equal to 1 to n x I minus x bar xj minus x bar. Okay, right. Now understand one thing. So in this term there is no term of involve any j. There is no term of involve any j. In this term there is no term of I. So you can write in this way. This is summation j equal to 1 to n and summation I equal to 1 to n x I minus x bar square. Okay. Now think about this term. Okay. So what is the value of this term? So now what is the value of variance? So if anyone remember, so sigma square is equal to 1 upon n summation I equal to 1 to n xi minus x bar square. So n sigma square is nothing but this is equal to summation I equal to 1 to n xi minus x bar square. And similar way n sigma square is also equal to summation if I vary j equal to 1 to n. If I vary j equal to 1 to n xj minus x bar. कोई problem? Remember one thing here also. Summation xi minus x bar, this quantity I equal to 1 to 1 equal to 0 because this is the deviation from mean and algebraic sum of deviation from mean. This is 0, right? This is 0. Summation I equal to 1 to n xi minus x bar equal to 0. So now you can apply property here. So this quantity, write this quantity, and here you also write this quantity. Okay. Now attention, in this quantity minus 2 summation I equal to 1 j equal to 1 xi minus x bar xj minus x bar. So I वाले term को you take I in term of I summation and j in terms of j summation. So when you take I in terms of I summation, so 2 summation I equal to 1 to n, you will get xi minus x bar. And in j summation, j equal to 1 to n xj minus x bar. Okay, so these quantity go to 0. This quantity go to 0. Why this quantity go to 0? This quantity go to 0. Why this quantity go to 0? This quantity go to 0 about algebraic sum of deviation from mean, right? Okay, so this quantity go to 0. So this whole quantity, this whole quantity, I am highlight this. This whole quantity, this whole quantity go to 0. This whole quantity go to 0. And why go to 0? This is an important. Okay, so this is go to 0, the algebraic sum of deviation from mean. Now understand. So first term here, if I put the value of this is, so this is summation. So this is summation j equal to 1 to n. This is n sigma square. This is n sigma square. This quantity value n sigma square. This quantity also value n sigma square. So this is summation I equal to 1 to n sigma square and then 0. So you will get what? You will get summation I equal to 1 to n and summation j equal to n to n. So okay. You will get summation I equal to 1 to n sigma square. नहीं यहाँ j था. Here is j. Here is j equal to 1 to n plus n sigma square and summation I equal to 1 to n sigma square then 0. So here it doesn't involve any term of phi and here doesn't involve any term of j. So this quantity equal to n sigma square into n plus this is n sigma square into n. So this is equal to 2n square sigma square. And this sigma square is what? This sigma square equal to variance of x. Remember that thing. This sigma square equal to variance of x. Okay. Here remember this thing. This sigma square is nothing but this sigma square is variance of x. This is variance of x. So here you will get what? You will get 2n square variance of x. This is the value of 2n square variance of x. This is the value of this quantity. This is the value of this quantity. This is the value of this quantity. Okay. This is the value of this quantity, right? This is the value of this quantity. Okay. So I am open this quantity. Na? This is the value of this quantity, right? I am open this quantity. So the final value of this quantity is what? So final value of this quantity is 2n square and variance of x. You can prove this. You proved this. You already proved this. Okay. 2n square variance of x. Okay. Here you see here. This is 2n square variance of x. So when you apply the when you put the value in this equation, this value is 2n variance of x, and here you apply the value. So you will get 1 upon n square into 2n square variance of x. This n and n square cancel out n square. You will get 2 variance of x. If anyone any doubt, wait a second. Okay. Actually, this pen is visual. This pen is visual or not?
So this is not visual.
This is not visual. Okay, right.
No,
Wait a second. It is visual?
yes, sir.
Wait a second. Wait. Okay. Now it is visual. Okay. Black is visual. So this is 1 upon n square into 2n square and variance of x. So n square is cancel out. You will get 2 variance of x. 2 variance of x. Okay. Here the value of this value is equal to this value. This quantity value equal to 2n square. You already proved this. Okay. You already proved the value of this quantity equal to 2n square variance of x. And proof of this equal is this. Proof of this is this. This. Okay. This is the proof of 2n square variance of x. So if anyone doubt regarding this proof, you can ask. Otherwise, I will end it here. I will stop here meeting. Okay. Anyone any doubt regarding any slide? Otherwise, I will be stop here meeting. So okay. Thank you, everyone.
Thank you, sir.
Thank you.